Okay, so hi, this is Will, and what we're going to do today is we're going to start looking at some of our other components that we can put into our ladder logic. And the first one is going to be timers. Timers are used a lot. You need to count time for a lot of different functions. For instance, if you have an event happening, like if I hit my start process, but then I want something to happen 10 seconds later, I need a timer. Likewise, if for some reason after I hit you might have a warm-up period. So before anything actually happens with your system, you want to wait a certain time. You need a timer. So what we're going to do is I'm going to put my timer in here, and here's where we have timers and counters. So if you highlight where you want to put it, and I'll delete my green lamp, but if I hit timer, it's going to put it where that box is, like anything else. Wherever we put it, it's going to put that thing. Now, it won't allow me to put a timer down here. Timer is kind of like the output, just like a coil. And basically everything down here, except what's in this first box, and there might be a couple of things, but they're all outputs. So I'm going to put my timer, and I'll call this T1. And I am going to set this for 15 seconds. Now, by default, it always goes into milliseconds. That's what the little m means. So you have to change it into seconds. And you can have seconds, minutes, hours, days. We'll put it at seconds. Now, here's what it shows what this actually does. When I enable it, and I'm going to enable it with the start process, but when I enable it, it's going to count for 15 seconds. When it gets to that set point, the output is going to go high. Now I'm going to have that output turn on my green lamp. So it'll be just like before, but when we hit start process, we're going to have this delay of 15 seconds before our lamp goes on. There's also this off timer, which we're not going to demonstrate because it's rarely used. And it's kind of backwards. You have to enable it to set the output high. And then when the enable goes low is when it actually does the timing. And after it times out, it goes low again. So it's one of those devices that's really quirky in how it operates. You kind of use the enable to preload it to this value where it's high, and then it counts when it goes low again. And that's one of the reasons it's rarely used. And we'll just leave it at that. If you want to experiment with it, fine. So here's what it looks like. It tells you that it's a T-on timer, T1. The output, so it's timer T1, and the output's also called T1. And I've given it a name for it's my start timer timeout. And here is my set point. Now here, the timer is T1, but this TD1 is an integer that's the running value of the timer. So it's counting up from 0 to 15. At 15 this goes high, but this will show you where in that it is. So when it's counting 7, 8, you'll be able to see it right here. So let's see, I said I was going to put in a green lamp. So I need to insert a rung after the cursor, and I'll put in a normally open contact, and this is going to be my T1 contact. And on the output, I'm going to put a coil. And hopefully by now you're getting used to our addresses. For the green lamp, it's 003. So that'll be our green lamp. So that's our circuit. It'll be just like before, except now we're going to have this, as we were talking about, it'll be a delay of 15 seconds before this goes on. So I'm already connected, so I can just write the project into the PLC. And you're good there. So we'll go through the regular stop the PLC and restart the PLC. And here we're going. So here you can see this will be the running value, the real-time value as we're counting to 15. So our red lamp's on. As soon as I hit start, it's going to go off. And now our green lamp isn't going on until it's at 15 seconds. When this goes to 15, our green lamp is going to turn on. So here you can see the count is at 10. When it gets to 15, that'll go turn on. Okay, so that worked fine. Now, you'll see in this process, it keeps counting. and we only have one input for control of this timer, and so it is going to keep counting. Well, count up the counter that it has inside its timer. It can only time out, and I keep using count, it's really time. It can only time out to, it's an integer value, and the maximum value it can time to is like 32,768. So it's going to count for a long time. If we get rid of the start process by hitting the stop push button, this will immediately go back to 0. And obviously the green lamp will turn off. So one of the things that these timers that they use a lot for, and we're still going to have it at 15 seconds, but let's pretend we were counting seconds and we counted up to 60. And when it got to 60, we called that our timeout. Because we want to count minutes, you can recycle these timers if you take this and you put it in here with a normally closed contact. So I want to go in here. I'm going to put in my normally closed contact, and I'll make this T1 again. And now what's going to happen when I do this? Now we aren't going to see the green lamp turn on, because it'll actually turn on for one scan. When this goes high, it'll turn on for one scan, but then it'll immediately come back when it runs through the program again. This will be high, so that'll be low, which will reset it. So this is just going to continually count from 0 to 15. You won't really see it light the green lamp. So let's just take a look at that. This is one of the ways that you use these timers. It's kind of like a free running timer. It counts up to a value and then immediately starts over again. So we'll write this into the PLC, and all we're going to do is we're going to watch it count to 15, and it'll just keep counting 15, keep counting to 15. And then we'll kind of show you why we would use this in a circuit. Because when we want to make lights blink, or we want to do other functions, we kind of use this in tandem with a second counter, or second timer. And they work together to, one timer turns on the other timer. So again, it counts up to 15, but then it just goes right back to 0. And it just keeps recycling. And on the face of it, you're like, well, that's not that grand of a scheme. But let's, and now I am going to turn off my PLC, because I'm going to make a couple pretty substantive changes. And you don't always have to turn off the PLC when you're making small changes, but if I'm making considerable ones, I usually do. So what I need to do is I need to insert, let's see, I want to insert at least 2 rungs, and I'll probably have to insert another one afterwards. But the first thing I'm going to do is I'm going to put in another timer circuit, and it wants to be just like this one pretty much. So I'm going to copy it, and I'm going to paste it on this rung. Now the first thing I'm going to do is I'm going to change this to timer T2, and I want to shorten up the time period. So I'm going to change that to 5 seconds. Still going to be my T-on timer, and that's what we're going with. Now this one's going to time out, and now when this one times out, I want to turn on this one. So instead of this normally closed contact, I really need this to be a normally open contact. And when you go from the instruction set on the top ribbon, if I just want to change that from normally closed to normally open, all I do is hit normally open and hit OK. And so it gives me the same parameter, it just changes the gate. So now when I'm starting process and this hasn't timed out, this will be counting, and then when that one has timed out, this one will be counting. So what I'm going to do when this one is counting, and when it's counting, actually when it's counting is when it's enabled. So I'm going to turn on my yellow lamp for that. So I'm going to make this same thing here for my yellow lamp, and then I'm going to, when this one is enabled, I'm going to turn on my green lamp. So I'm going to go into this rung, and I'm going to say I want a normally open contact, and I want this to be C2, and then next to it I want a normally closed contact, and it wants to be T1. So there's my T1. And okay, and then on my output, I'm going to make this coil. I'm going to make this my yellow lamp, which again, my yellow is going to be Y002. And that's okay. Now I'm going to change this one around, and I do need the T1, but really I'd like it to look pretty much like this one looks. So what I'm going to do is I'm going to change that one. I'm going into the instruction contact. I still want normally open, but I'm going to change that from T1 to C2. And then in here I'm going to put the normally open contact. And this will be, again, T1. So what I'm doing for both of these is, when this is enabled, it's timing. And when it's timing is, you know, when it's started for the process, but it hasn't timed out. That's when it's timing, when it hasn't timed out. Now this one is timing. I could do the same sort of setup, but this one is really timing when it started, and this one has timed out. Now what I need to do is I need to add one more thing. I'm going to add it after these two lamps. Is I'm going to have to recycle these timers. And so I want to add a rung afterwards. And when do I want to recycle them? I want to recycle them when they're both high. So I want it when it's T1 goes high and another normally open contact, and I want this to be my T2. So when both of those are high, I want to recycle these timers, and I want an output coil, and I want this to be one of my internal C bits. And again, when you're making up programs, and I have a C5 as my recycle timer, so I'm going to go in there. Now before we were recycling this first timer, remember, with this T1. So when this went high, this went low, and that just automatically recycled it. So now we're going to do the same thing, but we're going to change this to C5. So again, I'm going to go in here, and I'm going to go in my instructions, and I'm going to make this a normally closed contact, but I'm going to change it from T1 to C5. So again, this happens for one scan. As soon as this goes high, this goes low, and this resets it. It's exactly like what we had when we were just using the single timer. So now we're going to connect up, and we're going to not read what we have in there, and we're going to load it into the PLC. So we're right in the project. And now again, what we're going to see is when this one is counting, the first one, the yellow lamp is going to be on. And so the yellow lamp is going to be on for 15 seconds. And then when this starts counting, the green lamp's going to go on. And because we have this recycle counters, it's just going to keep continuously going back and forth between these two counters. And it'll be doing that for as long as we want. If we need a on-off cycle between things, one of these can be on, one of them can be off, and they can control something on or off. If we want to blink a lamp, we want it to blink at a 1 second rate. We use these two timers as one of the ways that we do it. It's probably the most popular way. So let me get started here. Anyway, we're on red because we're not started. Now as soon as I hit this, my yellow lamp will go on, which it does. And it's going to go on, it's going to stay on, and we can see the count here. It's going to stay on for 15 seconds. And then it's going to transfer control over to here, and then the green lamp is going to go on. And that's only going to go on for 5 seconds. And then it's going to transfer back because of our recycle timers. Now again, when it does this recycle timers, you really can't see that. You'll be able to see when this goes high, but you are not going to be able to see when this goes high because, again, it's going to happen for one scan. So this circuit is working. This is recycling everything, but it's nothing you can see. When we have things that happen for one scan, you know, there's no way to observe it. If the circuit's working, you know it's doing its job, because that would be the only way to recycle this back to zero. It's the same concept as when we had the single timer up here and we were using that output to recycle it on the input. So that's what these timers used. Now we're going to use its cousin, a lesser used version of it, but it's where you can retain these values, and it has some really useful functions, and we'll take a look at that next time. So thanks.